There's a pipe buried in your backyard right now that could cut your heating bill by half, and there's a decent chance you've never even heard of it. Not solar panels, not some gadget you plug into an outlet. Just pipe, water, and dirt. For every dollar of electricity it uses, it hands back roughly $3 to $4 worth of heat. That's not a typo, and it's not a scam pitch. It's basic thermodynamics, and it's been sitting under people's lawns since the 1940s. Here's the problem most of us are actually living with. Your furnace burns gas to make heat, and no matter how efficient it gets, it can never give you back more energy than the fuel you paid for. The best units on the market top out around 97 or 98% efficient, which sounds impressive until you realize that's the ceiling, not the floor. Meanwhile, your air conditioner is doing the opposite job, just as inefficiently, straining hardest exactly when the outside air is hottest and least cooperative. You're paying twice for two separate machines, both fighting against the weather instead of working with it, and every year the bill creeps higher. But here's the part. Almost nobody puts together. A few feet under your yard, past where frost ever reaches, the ground barely changes temperature at all. Heat wave in July, blizzard in January. 6 feet down, it's sitting around 50 to 55 degrees Fahrenheit, almost year-round across most of the country. The Earth is basically a giant thermal battery that never runs low. People just stopped paying attention to it. They didn't always. Root cellars, earth-sheltered homes, even wine caves. Cultures for centuries have exploited the fact that soil holds a steady temperature better than air ever will. The modern version of that idea traces back to an engineer named Robert Weber, who, in the years after World War II, ran coiled pipe through his own basement and backyard, circulated fluid through it, and heated his entire house using nothing but that steady ground temperature. Neighbors reportedly thought he'd lost his mind, right up until they saw his heating bill. The idea got a real shot in the 1970s, when the oil crisis sent energy prices soaring and rural homeowners with the land to spare started digging trenches. Then oil prices dropped, urgency evaporated, and 4 decades of home construction quietly defaulted back to gas furnaces and window units. The technology didn't fail, it just stopped being anyone's priority. So what's actually happening underground? You bury a closed loop of pipe, fill it with a water and antifreeze mix, and let it snake through the soil. That fluid comes back into the house at a steady 50-something degrees. Colder than you'd want in winter, sure, but way warmer than the freezing air outside. A compact unit inside the house, roughly the size of a furnace, takes that mild fluid and runs it through the same basic refrigeration cycle that powers your fridge, just aimed a different direction. The fluid picks up warmth from the ground, a refrigerant absorbs it and evaporates, a compressor squeezes that vapor until it gets seriously hot, and that concentrated heat gets pushed into your ductwork. In summer, flip the switch, and the whole cycle reverses. Heat gets pulled out of your house and dumped into the cool earth instead. One machine, one buried loop, handling both jobs. Here's the number that trips people up. A well-designed system can return 3 to 5 units of heat for every 1 unit of electricity it consumes. The Department of Energy backs that range, and the EPA has called ground source systems among the most efficient heating and cooling technology available today. It sounds like it's breaking the laws of physics, but it isn't creating energy. It's moving heat that already exists in the ground, and it only spends electricity on the pump and compressor doing the moving. That's the whole trick. You're not generating warmth from nothing. You're relocating warmth the Earth was already holding for free. So why isn't this in every new house? Mostly because nobody in the chain of decisions has a reason to push for it. Home builders compete on the price tag that shows up at closing, and a standard furnace and AC setup is the cheapest combination that passes inspection. The installer isn't the one paying the power bill for the next 30 years. The family who signs the mortgage is. On top of that, drilling or trenching a loop field usually means permits, zoning checks, and well regulations that vary by county. And in a lot of places, there's no streamlined process for approving one at all, plus a thin pool of certified installers. None of that is a conspiracy. It's just friction, stacked in enough places that most people give up before they start. And it doesn't help that a gas furnace generates decades of service calls and replacement parts, while a loop that lasts 50 years, paired with a compressor that lasts 20, just doesn't create much repeat business for anyone. The proof isn't hypothetical, though. School districts across the Midwest have buried loop fields under parking lots and athletic fields and cut their energy costs dramatically, with some systems running 2 or 3 decades on nothing but routine indoor maintenance. Homeowners who have made the switch commonly report their heating and cooling costs dropping by 1/4 to half compared to what they were paying before. If you're actually considering this, there are 3 ways in, depending on your budget and your appetite for weekend labor. The full-service route means hiring a geothermal contractor who sizes the system, drills or trenches the loop field, and installs the indoor unit, typically $15,000 to $35,000, depending on your soil and whether you need vertical boreholes through rock or a simpler horizontal trench. As of 2025, the federal residential clean energy credit covers 30% of that cost with no cap, and plenty of states stack additional rebates on top, which usually brings payback down to somewhere between 5 and 10 years. The middle option is hiring out just the drilling and handling the pipe assembly and indoor connections yourself, which can shave thousands off the labor cost. And the fully DIY version, renting an excavator, trenching by hand, fusing high-density polyethylene pipe with a heat welding tool, and buying the indoor heat pump unit separately, has gotten committed homeowners into the low thousands in materials. None of this is a free lunch, and it's worth being upfront about that. Horizontal loops need open ground, so small urban lots often aren't candidates. Vertical boreholes work on tight lots, but drilling through rock gets expensive fast. Retrofitting under an already finished house with a paved driveway is far more disruptive than installing during new construction. And this still isn't a zero-bill machine. The compressor and pump run on electricity, so you're shrinking your energy use by a factor of 3 or 4, not eliminating it. If your electricity rates are high, the math gets tighter. This is a serious upfront investment that pays off over years, not an instant fix. What strikes me most about this isn't really the pipe or the compressor. It's how many good, boring, already proven ideas get quietly shelved, not because they stop working, but because nobody's business model depends on them working. The ground under your yard has been sitting at a steady temperature for longer than any of us have been alive, completely indifferent to what's happening in the energy market. Whether anyone bothers to use it is a decision, not a law of physics. That's worth remembering the next time something described as too simple to be true turns out to just be true and inconvenient. Hidden fix lab.